Hello everyone, welcome to another episode of Deep Dive Knowledge. Can you explain the concept of the H3 index and how it works in analyzing geospatial datasets?
Sure. The H3 index is a geospatial indexing system that uses a grid of hexagons to analyze and partition geospatial datasets. It works by dividing the Earth's surface into hexagonal cells of different resolutions. These cells can be thought of as building blocks that cover the entire world. The H3 index uses a hierarchical approach, where each hexagon at a lower resolution contains a set of smaller hexagons at a higher resolution. This hierarchy allows for more detailed analysis of geospatial data. Each hexagon in the grid has its own unique ID, which helps in identifying and accessing specific areas on the map. To analyze geospatial datasets, the H3 index provides the ability to adjust the resolution of the hexagonal grid based on the problem at hand. This flexibility allows users to scale the grid up or down, depending on the level of detail required for analysis. Additionally, the H3 index covers the entire world, enabling analysis of any location on Earth. By using the H3 index, analysts and developers can efficiently analyze geospatial data, such as optimizing ride pricing and dispatch, visualizing spatial data, and making citywide decisions. It provides a powerful solution for working with large-scale geospatial datasets and enables accurate analysis by partitioning the globe into hexagons.
That's fascinating. The hierarchical approach of the H3 index seems quite powerful. Can you explain how the hexagonal shape of the grid simplifies calculations and provides a more accurate rest study of distances compared to other shapes?
The hexagonal shape of the H3 index grid simplifies calculations and provides a more accurate race study of distances compared to other shapes because it has a unique property. A hexagon has only one distance between its center point and its neighbors, whereas squares have two distances and triangles have three distances. Think of it this way. Imagine you have a triangle, a square, and a hexagon, and you want to measure the distance between their center points and their neighbors. For the triangle, you would need to measure three different distances. For the square, you would need to measure two different distances. But for the hexagon, you only need to measure one distance. This unique property of the hexagon simplifies calculations and makes it easier to perform analysis and smoothing over gradients. It also allows for a more accurate rest study of distances in the H3 index grid. This is why the hexagonal shape is chosen as the base shape for the H3 index grid.
I see how the unique property of the hexagon simplifies calculations and provides a more accurate rest study of distances in the H3 index grid. Now, can you explain how the different levels of resolution in the H3 index are useful for flexible analysis based on the problem at hand?
The different levels of resolution in the H3 index are incredibly useful for flexible analysis based on the problem at hand. Just like how you can zoom in and out on a map to see more or less detail, the H3 index allows you to adjust the resolution of the hexagonal grid to suit your needs. Imagine you're trying to analyze data about population density in a city. If you need a broad overview, you can use a lower resolution of the H3 index, which will give you larger hexagons covering bigger areas of the city. This will help you understand the overall trends and patterns of population distribution. On the other hand, if you need a more detailed analysis, you can use a higher resolution of the H3 index. This will give you smaller hexagons that cover smaller areas of the city, allowing you to examine specific neighborhoods or even individual buildings. By having multiple levels of resolution, the H3 index allows you to easily scale the grid up or down depending on the problem you're trying to solve. This flexibility is what makes the H3 index so powerful for geospatial analysis.
That's a great explanation of how the different levels of resolution in the H3 index provide flexibility in geospatial analysis. Now, I'm curious about the applications of H3 index with generative AI. How does the H3 index technology contribute to generative AI application development?
The H3 index technology contributes to the development of generative AI applications by providing a powerful and efficient way to represent and analyze geospatial data. With the H3 index, geospatial data can be organized into a hierarchical hexagonal grid system, allowing AI algorithms to easily access and process location-based information. generative AI applications often involve generating new data or models based on existing patterns or data sets. The H3 index provides a flexible and scalable framework for organizing and analyzing geospatial data, which is crucial for many generative AI tasks. For example, it can be used to generate realistic and diverse synthetic datasets that mimic real-world distributions and patterns. By using the H3 index, generative AI algorithms can efficiently explore and understand the spatial relationships and patterns within the data. It enables AI models to generate new data or make predictions at different spatial resolutions, allowing for more accurate and meaningful results. Furthermore, the hierarchical nature of the H3 index allows AI models to work at different levels of granularity. It provides a way to zoom in or zoom out on the data, depending on the specific task or analysis. This flexibility is especially beneficial for generative AI applications, as it allows models to generate data at different scales and levels of detail. Overall, the H3 index technology enhances the capabilities of generative AI applications by providing a powerful and flexible framework for organizing, analyzing, and generating geospatial data. It enables AI models to understand and generate location-based patterns, leading to more accurate and realistic generative outputs.
Thank you for explaining how the H3 index technology contributes to generative AI application development. It's impressive how the H3 index enables efficient exploration and generation of geospatial data, while also providing flexibility in terms of granularity and scale. This combination of capabilities is certainly valuable for generative AI tasks.